basic information to solve the problems of the molarity and normality, and these basic concepts are also helpful for the remaining topics, atomic structure, chemical bonding and a periodic table and some other groups is also. This basic information very important that. So now before going to the class, our basics concept, just to recall our previous class. So in the previous class I have to tell about the solutions topic. In a solution topics I have to explain in definition of the solutions, and next one characteristics of the solution, next one types of solutions, and these basics are all explained in the previous class. Once again I have to recall the previous class, because of this recall is very important for the this recall is very important for the students. Once again I have to explain the previous class. What is the definition? What is the definition of the solution? Is nothing but a homogeneous mixture of two or more components. Two or more components is nothing but salt plus water, like NaCl plus water, NaCl plus water. So it forms a homogeneous. Homogeneous means is a single phase. We take the salt water, it can be appeared as a single phase, but it has only two components. In two components, if one of the solute, one of the component can be separate or vary within certain limits, that is known as the solutions. Again I have to say that definition of the solution is nothing but the homogeneous mixture of two or more components whose component may vary with certain limits or certain methods is known as solution. That is the solution of the definition of the solutions. If in a solution is equal to both solute and solvent, solute plus solvent. So in this solution, so NaCl can be accessed as solute because of it is the less quantity. Next one, the solvent is the large quantity. So in a solution, less quantity can be behaves as a solute, large quantity can be behaves as a solvent. In a solutions, the large number of components are there. Even if we take in a solution, only two components are there. So it is known as binary solution. Binary solution. What is the meaning of bi? Means is a two, and in a solution there are only two components. In these two components, one is the solute, another one is the solvent. Next one, if we take the trinary solutions, the trinary means that is the three. Trinary solution. This means tri means this is the three components. If like I say NaCl plus MgCl2 plus water, in this solution there are three components are present. So this is the small quantity, like as a 10%, but it is a 20%, but it is the 80% are there. If the component can be exist as a large proportion, that is known as it can be accessed as solvent, but remaining two are the small proportions, so that's why it can be accessed as solutes. So it is a binary solutions or a trinary solution. So one must be solvent and remaining all are solutes, because of in a solutions large proportion is considered as a solvent, but remaining all are is considered as a solutes because of it is the lesser proportion. So we can take the in a solution having 100 components, 1, 2, 3 and so on. These all are the all components. So in these components only one component can be exist as a higher proportion, it can be accessed as a solvent, but remaining all are can be accessed as a solute. So in a solution, different types of solutions. In all solutions, the solvent can be only one component, but remaining all are can be accessed as a solute. So this is the types of solution, and this is the definition of the solutions. The homogeneous mixing both the solute and solvent can be exist in a single phase phase only. Best example we take is a milk. Milk is also a single phase, like as a homogeneous phase, but it exists. But in this milk has a two components. One is the milk and another one is the water. So in this milk, both milk plus water. In this milk, so it has a 15% and water is a 85%. So that is here water is exist as a solvent because of the larger proportion, but is the milk is a smaller composition. That's why it can be acts as a solute. So milk is also exist as a single phase, like as a homogeneous phase. As I already in the previous class, the board and my class is the very speed. That's why now I have to as in the other class, in the previous class, so many errors I have seen. So that's why today I will fill the all errors in this class and also give the basic information as the very best information. That information gives a lot of confidence to solve the another problems and easily solve the other problems and easily get the subject. So we have to go to the another next definition is over. Next one, different types of solution is over. Next, go to the characteristics of the solutions. What is the characteristics of the solution is nothing but the formation of the solution. The formation of the solution is always a physical change, not a chemical change. Next we are go to the characteristics of the definition is the over. Already said that. Next one is the characteristics of the solutions. In this characteristics, first point is the solution must be, already said that the solution must be homogeneous. Next one, the formation of solution. The formation of solution is physical change, not a chemical change. Next, third point. In this third point, solution having both solute and solvent. In the solute having both, one is volatile solute and another one is non-volatile solute. So in this solution, the solute can be separated. So it can be separated by using distillation, evaporation, crystallization. Next one, adsorption also. These are the can be useful for the separation of the solute from the solution. That is a best example. Best example, salt water. We can take the salt water in a test tube. So both solute and solvent is present. Like I said, salt water in the solution, both salt and water is there. We have to apply some heat at 100 degrees centigrade. The boiling point of the water can be escape. So then the salt can be settled down of the precipitate test tube. So it can be easily separated by using the evaporation process. So and also crystallization process. It is also a crystallization process is also applicable for sugar solution. So crystallization of the sugar and the pure formation of the sugar and like this. These all are the can be useful for the separation of the pure components. Separation of the pure components from the impurities and solvents like this. So these are the only method for the separation of both solute and solvent in a solutions. If the compound contains, if a solution contains a non-volatile solute, in a solution some of the compounds are a non-volatile solute also. Best example, take water in oil. So this is the water and it can be having some oil drops. So these oil drops is present on the surface of the liquid. Then we have to separate both oil plus water. If we have to apply some heat, So at 100 degrees centigrade, water will be evaporated, but in this case, the oil will be obstructed to stop the evaporation of the water. So in this case, first of all, oil will be evaporated, then only the water will be evaporated. So in this case, at 800 degrees centigrade, then only oil will be evaporated, after the water will be present. So it can, by using these different conditions, different temperatures, we can be easily separate the both oil and water completely. So these are the pure form of the compounds like this. Similarly, at the same time, alcohol and water, alcohol plus water, in this case, so both and water and alcohol are in the same phase, so this is called a volatile solute. So in this, alcohol having the only 57 degrees centigrade, so water is 100 degrees centigrade. So at the low temperature condition, the alcohol will be easily evaporated through a pleasant smell, so and the water will be remaining. So by using different types of the conditions, by applying distillation, evaporation, crystallization and adsorption, by using these methods, we can be easily separate the solute from the solutions. So these are the characteristics of the solutions. Next, next one is the types of solution. So basing types of solution is based on solvent. Based on solvent, so it can be cleavaged as a aqueous solution and a non-aqueous solution. So because of in aqua means is the water. Aqua means water. So in this solution, aqueous solution, water can be acts as a solvent. Next one, in non-aqueous means, so there is no water. So here condition, alcohol, acetone, all organic compounds can be acts as a solvents. So these all are also known as non-polar solvents. Non-polar is nothing but there is no polarity, there is no positive charge and no negative charge. So these are the types of solutions based on their solvent. So based on their physical state. In the previous class, the writing will be very small, so then that's why I have to clear all that errors today. So so in the basing on their physical state, so we have a lot of examples. So that is the solid in solid. Next one is the solid in a liquid. Next one is the solid in a gas. Similarly, so next one, solid in a liquid, liquid in a liquid, gas in a liquid. So there are the 9 types. So solid in a solid, already I explained. So these are the alloys. Brass, bronze, steel, like as a gold. So it is a gold also is a one of the alloy. So gold is the best example. So this is a very easily understand. That's why I have to say I have to take the gold example. In this gold, so in the composition of the gold is both iron and copper. So all the pure form of the all metals, in any metal we have to take any metals, the pure form of the all metals is a malleable property. అవన్నీ కూడా ఎలా ఉంటాయంటే చాలా మెత్తగా ఉంటాయి, వాటికి హార్డ్ నేచర్ అనేది ఉండదు. కాబట్టి ఏం చేస్తా ఉంటే we have to added some impurities, then impurities is added, the metal will be is converted into hard. So in this gold, so you have 24 carats gold, 22 carats gold is a 916 carat gold. So in this 24 carats gold, so there are 22 carats of the gold and 2 carats of the copper. These 2% of the copper is added to the iron, so the iron can be converted into a brittle nature, so it's a hard nature. That's why we have to impurities added to the Similarly, if iron is also malleable property, so in this iron, so we have to add it to the carbon. So if the carbon is added to the iron, so it will be hard in nature. So the basic principle, some of the impurities is added to the metals, so it can be easily converted into hard. Okay. Next go to the solids in a solids. Next one is the liquids in a solids. So the liquids in a solids is the best example for the liquids in a solids. Liquids in a example is the amalgam. What is the meaning of amalgam? Amalgam is a mixture. So mixture is nothing but it is compulsory the two components. So in these two components, so one must be mercury. And the another one is that we have take any metal like as a sodium, and we take the magnesium, and remaining whatever any metal we have to take. So in this mercury can be behaves as a liquid state. In this period, in our periodic table, so there are some metals can be exist as a liquid state. So one of the mercury పాదరసం అనేది liquid state లో ఉంటుంది. Already మనకు తెలుసు in thermometer you can use the Hg, so that is the liquid state. So that is called liquids in a solids. Sodium, it is a metal, so it is a solid. Magnesium, it is a metal and it is also solid. So that's why amalgam can be best example for the liquids in a solids. Next one, already said that solid in a solid is over. The best example is for alloys. Next one, gas in a solid. Gas in a solid is example for the occlusion of hydrogen with metal. Hydrogen with any metal or palladium or platinum or whatever it may. If the metal surfaces, some of the gases will be occlusion on the metal surfaces, like as a oxygen, it will helpful for the rusting purpose. So these are the occlusion of the hydrogen with the platinum. So this is the example for gas in a solid. Next we have to go to another example for the types, different types, that is called for liquids, and is nothing but liquids in solid. Next, already is over. Solids in a liquid. Solids in a liquid. Liquid in a liquid. Next one, gas in a liquid. So gas, solid in a liquid, it is a solvent, so this is the solute. So solid in a liquid is sugar plus water or salt plus water. So this is the example. So sugar in water, so this is the higher proportion, so it can be accessed as solvent, so it is a solute. Liquids in a liquid, so it is an example for alcohol in water. So this is also one of the example. So gas in a liquid, so is the best example for the soda water. So in soda water, so water is water is treated as a solvent, and soda, like I say, soda water it is nothing but a CO2. So CO2 in water, so that is called CO2. It is a lesser proportion. That's why it is a solute and it is the solvent. So this is the another example for the solids in a liquids. Next one, go to the another example. So that is solids in a gas, liquids in a gas. Next one, gas in a gas. So this is also one of the another example for the another type of the solution based on their physical state. Solids in a gas, so best example is the camphor. Already in the previous class I will said that camphor is a gaseous state under high pressure condition, so it can be exist as a solid. That's why the camphor is a burn, it is completely converted into solid to gas, not a liquid. So that property is known as the sublimation property without emitting any. So if the conversion of solid to liquid is Solid to liquid is the melting, so liquid to gas is the vaporization. So the conversion of solid to gas is directly, it is known as the sublimation. Similarly, the gas into liquid is known as condensation. So condensation. Next one, the liquid is converted into solid, that is known as the freeze. That is known as the freeze. Next. So this is the one of the example for the solid in a gas. One of the example is the camphor. Next one, liquids in a gas is the best example for the moisture. In winter season, snow. In a snow, the air is occupied with some of the liquid air, some water droplets. So in this gas can be like as a bubbles. In this bubbles, so the air is completely occupied with some liquid. So that's why it is the best example for the moisture. In this moisture, both air plus water. So similarly, next example is gas in gas. That is the best example in atmosphere. That is called is the air. In this air, already said that so 78% of the nitrogen, similarly 20% of the oxygen, remaining 2% of the CO2 and argon, remaining different compounds. In this poly solution, so in this higher proportion, so it can be acts as a solvent. These all are the can be exist as a solutes. So this is the different types of the solution basing on the physical state. Already this class is already over in the previous class. Once again I have to explain because of the in the previous class I have to go to with a speed and it's the small letters. So by you according to this some errors, I have to clarify this all doubts in this class. So this is the different types of the solutions. Similarly, how to find out the concentration of the solutions and different types of the problems in a solution topics. Next concept, go to already I said in the previous class, gram molecular weight and equivalent weight. So before going to that equivalent weight and molecular weight, so we have some different types of the problems. We have to go to the some basic concept. These basic concepts are very helpful because of some freshers like as the 10th class students are going to the intermediate students. These students are also helpful, and the second year students, these are also helpful for recall the all basics and to helpful for the remaining concepts and easily find out and to form to fastness of this subject. So next, what is the some basics today. Some basics concept. What is the basic of the concept? For freshers, this concept is very helpful. Please listen and concentration. మీకు ఈ టాపిక్ అనేది ఎంత హెల్ప్ఫుల్ అవుతుందంటే అంత హెల్ప్ఫుల్ అవుతుంది. ఒక్కసారి కొంచెం జాగ్రత్తగా వినండి. మీకు ఒక ఎంత బేసిక్స్ గా వస్తే సబ్జెక్ట్ అంత ఈజీగా ఫామ్ చేసుకోవచ్చు. ఆల్రెడీ ఫ్రెషర్స్ ఉన్న వాళ్ళు ఖచ్చితంగా 1 to 30 ఎలిమెంట్స్ కంపల్సరీగా మనం నేర్చుకోవాలి. ఏమేమి నేర్చుకోవాలి అంటే వాటి యొక్క అటామిక్ నెంబర్స్ అండ్ దిస్ ఇస్ ద సింబల్స్. నెక్స్ట్ వన్ అటామిక్ వెయిట్స్. Next one, this is the electronic configuration. These 4 requirements can be. So this is the best. These are the basic concept. Next, I have to take a break. I have to continue this basics. The very important, friends. Please keep on watching live stream. Thank you.
విద్యార్థుల భవిష్యత్తుకు బాటలు వేస్తూ మునుపెన్నడూ ఎరుగని అత్యుత్తమమైన ఫలితాలతో అద్భుతమైన విద్యా ప్రమాణాలతో ముందుకు దూసుకుపోతోంది శ్రద్ధ జూనియర్ కళాశాల. మహబూబ్నగర్ జిల్లా కేంద్రంలో ప్రముఖులు అనుభవజ్ఞులైన చైర్మన్ జగపతిరావు ఆధ్వర్యంలో 2011లో స్థాపించబడిన మా శ్రద్ధ జూనియర్ కళాశాల ఉన్నతమైన విద్యా ప్రమాణాలతో ఇంజనీరింగ్, మెడికల్లో చక్కని ర్యాంకుల సాధనలో విజయం వైపుగా కృషి చేస్తోంది. ఇంజనీరింగ్ అయినా మెడికల్ అయినా శ్రద్ధ జూనియర్ కళాశాల విద్యార్థులదే పై చేయి. ఇంటర్ తో పాటు ఐఐటి, నీట్, ఎంసెట్ నందు లాంగ్ టర్మ్ ప్రోగ్రామ్స్ ద్వారా కార్పొరేట్ కళాశాలలో 20 సంవత్సరాల అనుభవం కలిగిన అధ్యాపక బృందంచే ప్రత్యేక శిక్షణ తరగతులు నిర్వహిస్తూ డైలీ ప్రాక్టీస్ పేపర్స్, వీక్లీ టెస్ట్, కౌన్సిలింగ్ ద్వారా విద్యార్థుల నైపుణ్యం మెరుగుపరచడం మా ప్రత్యేకత. హ్యాండ్బాల్, ఫుట్బాల్, క్రికెట్ లో మా విద్యార్థులు జాతీయ క్రీడాకారులుగా గుర్తింపు పొందుతున్నారు. జిల్లా కేంద్రంలో సొంత భవనాలలో కళాశాలలు, విద్యార్థులకు ఉదయం సాయంత్రం వేళలో స్టడీ అవర్స్, ఐఐటి, నీట్ లో ప్రముఖుల నిపుణులచే విద్యా బోధన, బాలికల కోసం ప్రత్యేక క్యాంపస్, ఎంపీసీ బైపీసీ గ్రూప్లతో కో ఎడ్యుకేషన్, ఎంపీసీ బైపీసీ ఎంఈసీ సిఈసీ గ్రూప్లతో గర్ల్స్ క్యాంపస్, ఎంపీసీ బైపీసీ గ్రూప్లతో పాటు ఐఐటి నీట్ ఎంసెట్లతో అకాడమీ.
I am Mariam Makbul. I passed out from SHRADDHA Junior College in 2017 from BPC. Currently, I have passed out from Tata Institute of Social Sciences. I finished my bachelor's. So one thing which is very striking about this institute is the immense and genuine amount of effort that the team of faculty puts and takes up for the success of students and their prosperity. And another thing that is very remarkable about this place is they ignited in me the spirit of competitiveness, which is very necessary in this globally evolving market world. There was one Sanskrit slok which which I learnt when I was very young. Udhyame nahi siddhyanti karyani na manorataihi nahi suptasya simhasya pravishanti mukhe mruga. This means you cannot just achieve anything just by thinking of it. You need to put in effort. That is what I have learnt from this institute. Like, even though lion is king of jungle, it has to hunt for its own prey, which is what I have learnt from SHRADDHA Junior College.
I am Uday Kiran. I have completed my intermediate in SHRADDHA Junior College in 2019, and I have joined Trinary Institute of Science and Technology, and I scored my JEE Mains percentile as 98.19, and due to some other problems I didn't join NIT, and I have scored my MCET rank as 4500, and here the lecturers take the special care with each and every student.
సీనియర్ మరియు జూనియర్ ఇంటర్ అడ్మిషన్ల కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల కో ఎడ్యుకేషన్ క్యాంపస్ మెట్టుగడ్డ. మీరు సంప్రదించవలసిన మా ఫోన్ నెంబర్ 9494430200. ప్రత్యేకమైన గర్ల్స్ క్యాంపస్ కోసం సంప్రదించవలసిన మా చిరునామా ఆపోజిట్ పంచవటి హోటల్, న్యూ టౌన్, మహబూబ్ నగర్. మా ఫోన్ నెంబర్ 7337294653. ఐఐటి నీట్ అకాడమీ కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల మెట్టుగడ్డ. మా ఫోన్ నెంబర్ 9491629962.
So welcome back to class. Next, so these are the basic concepts very helpful for the to solve the remaining all basics. So very important basic requirements. These are the to find remaining concepts. So next, 1 to 30 elements for the Z is equal to atomic number, at least 30 numbers. Next one, symbol. For example, take one example. It's a carbon. Atomic weight very easily because of if we know the atomic number, then that double the atomic weight. Best example, if the copper is 6 atomic number, atomic weight is double. Most of the 80% of the 1 to 30 elements, 80% of the elements can be double the atomic weight. That is known as the atomic weight. 6 is the double, that is known as the 12, that is the atomic weight. So next one, electronic configuration, that is the symbol. So now we have to briefly accept brief information about the element. So this is the for first year students. It is very helpful for you already in a 10th class. So I once again I can repeat. So in this carbon, what is the atomic number is 6. Configuration is 1s2, 2s2, 2p2. So we have to write in the valency shell like this: 1s2, 2s2, 2p2. We have to always consider as a outermost configuration. So this is the outermost configuration. So this is the inner configuration. Before this is called inner configuration. This is the outermost configuration. So by using this concept, we have to find valency, group number, and is also period number. These three can be easily find out by using this electronic configuration. Let me explain this. So by using this 2s2, 2p2. If the last electrons enters into the 2p orbitals, so that is known as a p block. Already it is a which block is a p block, because of the last electron, the incoming electrons enters into 2p orbitals. So that's why it is a p block element. Next one, the element can be outermost configuration 2s2, 2p2. That is called the second period. Next one. So we have to find easily P block, and it is a second period, and because of basing on the only outermost configuration, we can easily enter briefly information about the element. Next we have to go to the group number and remaining. So basically already we know that the period number, because of in our periodic table, so the horizontal lines is a periods, the vertical lines are the groups. There are 7 periods and 18 groups. So the carbon is a which group is the we don't know, but by using this electronic configuration we have to find easily group number. The powers, the summation of the powers, that is known as the group number. That is called 2 plus 2, that is equal to 4th group. That is called carbon is a 4th group. Next information is valency. Valency is nothing but a group number, but it is not all cases. Up to 4th group, group number is equal to valency. What is meant by valency? Valency is nothing but, best example I have to explain like this. So we can write hydrogen can be written as the H2. So oxygen can be written as O2. Nitrogen can be written as N2, but helium can be written as He2 is not applicable. So it can be written as the He only, not a He2. Similarly, neon can be written down as a Na but not a Ne2. Similarly, chlorine is written as a Cl2 also. Except inert gases, remaining all elements are in a combined state because of lack of stability. So why all elements are in a combined state is nothing but due to stability, to attain a stability. For the stability can be explained in outermost configuration according to octet. Octet is nothing but octet. Oct is nothing but 8. Octopus is nothing but 8. Oct is nothing but. In outermost electronic configuration, if an element having 8 electrons in outermost configuration, so it can be easily stabilized. So it's a neon configuration. Take one neon example. Neon atomic number is 10. Configuration is 1s2, 2s2, 2p6. So by using in outermost electronic configuration, outermost electrons are 8 electrons. So that's why it is a stable. That's why it cannot be combined with another neon to form a Ne2, because of already it is a 8 electrons. So it can be easily stabilized basing on their octet. We can go to the oxygen. We take oxygen. Oxygen having atomic number is 8. Configuration is 1s2, 2s2, 2p4. So in this oxygen atom, outermost electrons having only 6 electrons. So because of, if oxygen to attain a stability by the gain of 2 electrons, if the gain of 2 electrons to get a stability, that is known as the valency, the combining capacity. The combining is nothing but either loss of electrons or gain of electrons or sharing of electrons. How many number of electrons are sharing or losing or gaining, that particular factor can be decided as a valency. So because of why it is the valency is nothing but to attain a stability, how many number of electrons are gained or lost. Similarly, already carbon having how many number of electrons is there. So in outermost, so there are only 4 electrons. If to attain a stability, so 4 electrons are gained or 4 electrons are lost. So that is called the valency is 4. So that's why I'm already said that some of the compounds up to 4th group, the group can be existed as a valency. It's a very, very important valency. So valency is nothing but outermost electrons. The element can be having how many number of electrons in outermost shell. So the remaining elements, to attain a stability, the remaining elements can be decided the valency. Similarly, if oxygen having outermost electrons are 6, so it how many number of electrons are there? It gain 2 electrons. That 2 is known as the valency. Similarly, already carbon, the entire information of the carbon. So by using not only valency, we have to know about the oxidation state also. Valency and oxidation state both is a very easily just the sign only difference. Once again I have to explain like this. If we take another one more example is already it is the carbon is over entirely information. Next we go to another example, that is chlorine. we can take another one is a chlorine. So we can take chlorine is atomic number is 17. Configuration is 1s2, 2s2 basing on their molecular diagram. This is a very important. So 2s2, 2p6. So almost all can count 2 plus 2, 4 plus 6, 10 is gone. Next one 3s2, 12. Next remaining is 5. So that is called 3p5. So outermost configuration is 3p5. So by using this concept you can easily find out another element, brief information. Next, the incoming electron entered into p orbital. So that's why it is known as a p block. Block is over, which is a p block. Next one, the configuration is outermost configuration is 3s2, 3p5. So this 3 can be denoted as 3, that is called period, third period. Next one, so next one, power, summation of the powers. 2 plus 5 is equal to 7. That 7 can be denoted as a group number. If the chlorine can be attain a stability, already it has 7 electrons in the valence shell, it has only 1 electron to attain a stability. Ante the meaning of valency is, what is the valency of chlorine is only 1, because of already it has the 7 electrons in the valence shell. The only 1 electron to remaining to gain the 1 electron to attain a 7 plus 1, that is equal to 8 electrons can easily stabilize. You can take another one example like as a sodium. So all are the both are p block. We can go to the s block also, so you can easily find out the entire information of the element. Next one, we can take sodium. So sodium atomic number is 11, 1s2, 2s2, 2p6. Already the 10 is gone. So next one is the 3s1. Already I said, so we can take outermost configuration only 1s2, 2s2, 2p6. Next one 3s1. So there are the 12. So we have to take outermost configuration. We have to write the all information. So this is the incoming electron entered into s orbital. So this is called s block. Next, what is the period number? Is the outermost configuration is outermost, this is the third period. That is the third period. Next one, what is the group number? Is group number is nothing but powers, summation of the powers. In a valency shell, the only one power is there, that is called 1. So that's why sodium is the which group is the first A group. So this is the S block element, and this is the third period, and this is the first group. So in this concept, what is the valency of the sodium? Already I said that 1 to 4th group, up to 1 to 4th group, the group number is existed as a valency. Already if sodium having to attain a stability, it has only 1 electron. To gain of 7 electrons, then only it is an octet. But if the loss of single electron to attain a nearest neon configuration. That's why sodium metal can be easily loss of 1 electron. So that is called valency. Combining loss of single electron, that single electron can be exist as a valency. So already I said that 1 to 4th group number is equal to valency. So in this sodium atom, valency is equal to 1. So this is the information. We have to find block and period and group number. How to find out the group number is summation of the powers of outermost configuration. Both for P block, P and S can be combination. For D block, both S and D, so different can be easily find out the entire information of the that element is the which group and which period and valencies and which what is the remaining elements in that particular group, and easily find out the electronic configuration also. So this is the brief information about the elements. Of course, these electrons and protons and neutrons, these are the atomic structure. These are very basic concepts. So next, we have to go to the word formation to equation form. Word formation to equation form can be easily because of the already we know about the valencies. So can we easily find out the word formation to equation formation. This equation formation very easily helpful to find out the oxidation states and group number, how to cleavage, how many number of moles of element can be cleavage like this, how many number of oxidation states like this. So best example, we have to take another step to word formation to equation formation. We can applicable, it is also applicable for equivalent weights and molecular weights and different compound for acids or whatever, but word formation to equation formation. Best example, we don't know, word formation is sodium chloride. Best example, sodium chloride. So we don't know about the equation form. Then it can be split into two types. So that is called sodium and chlorine. What is the symbol of sodium is Na. Chloride is the symbol of Cl. This is the Cl. How can be write as a NaCl? That is called word formation to equation formation. How to NaCl is exist? What is the valencies? So for this sodium element, already we know that this is the first group. So in this first group, valency is 1. So for this, valency is 1. Similarly, chlorine has the valency is 1, also 1, because of in chlorine outermost electrons are 7 electrons. So it can only gain of 1 electrons. So similarly, chlorine valence is also 1. So we have to crisscross like this. So that is called Na1 and Cl1. So it can be written as a NaCl. So that is the word formation to equation form by using the elements and valencies. So it can be easily write down. So you have to go to another example. So magnesium chloride. We don't know about the chloride and magnesium, but again we have to split two types. So one is the magnesium, the symbol is Mg, the chlorine is symbol is Cl. We don't know about the Mg valency, but we know about the valence of chlorine, that is 1. So the valence of chlorine is only 1 because of outermost electronic configuration is, we don't know valency, so we have to atomic number 17, outermost configuration neon 3s2 3p5. So it has outermost electrons are 7. We have only 1 electron. That electron can be exist as a valency. Similarly, go to the magnesium. So magnesium atomic number is 12. So it can be treated as a Ne and 3s2. So for basic students, for intermediate first year students, these basic information is very helpful for to convert the word formation to equation form. That convert by using this equation, we have to find all like this. So first of all, go to the word formation to equation form. So by using this, if the what is the for this? So that is the third group, S block, and what is the group number is 2 because of powers. So powers is can be treated as a group. So that is the second group. So that is the S block. That is the third period because of outermost configuration. So that is called. So up to fourth group, 1 to 4th group, the group number is exist as a valency. So that's why. So what is the group number of the magnesium is? Group number is 2. So valency is also 2. So we can easily find out the group number, that is called 2. So that's why we have to crisscross like this, MgCl2. Magnesium chloride can be written as a MgCl2. So that is the word formation to equation form, can be easily find out by basing on their valencies and group number and period. So these are the basic information. By using this basic information, easily find out the remaining all concept can be easily find out. So this is the next one. So we take another example, that is called AlCl3. So we don't know AlCl3. Next one already AlCl3 already I said that. We have to go another example, like not a oxide, not a chlorides, and go to the different examples like oxides, magnesium oxides or sodium oxide, right? We have to write sodium oxide. we don't know about how to write the sodium oxide to equation write down. So but we don't know, but we have to cleavage like this. Sodium, we know what is the sodium symbol is sodium Na, and oxide is O, that is the oxide is O. But we know about the valencies of oxygen is 1, but we don't know about the valency of the oxygen. How to find out? But we have to say, go to the atomic number. So Z is 8. Configuration is 1s2, 2s2, next one, that is the 2p4. So by using, so we have to powers, summation of the powers is equal to group number, that is equal to 6. So oxygen has the 6 electrons in outermost orbital, 2 plus 4, that is equal to 6 electrons in outermost orbit. Then how many number of electrons to attain a stability, that is called as the 2. Already it has a 6 electrons, so go to the, if oxygen gain 2 electrons to attain a stability, because of already it is a 6 electrons is there, so totally 8 electrons, that 2 electrons is exist as a valency. Because of oxygen having the 6 electrons in outermost orbit, so we have to, how many number of electrons is remaining? Only 2. That 2 can be existed as a valency. So by using atomic number, we can be easily find out the valency, how many number of remaining electrons to attain a stability. So by using, so oxygen has the valency is 2, because of it has only 6 electrons in outermost. Again I have 2 electrons are gained, that 2 electrons can be exist as a valency. So sodium is a valency is a 1, but oxygen valency is 2. So by using this crisscross method, so we can be written as the Na2O1. So we can write as the Na2O, that is called sodium oxide. So this is the very, very important, friends. We have to find the sodium oxide. So for using the numerical problems, why you have to take, so A is a compound, sodium oxide A is a react with another compound B, magnesium chloride, what to form a C compound, what is the valencies and what is the compound name of the C component. ఇలాంటి టైప్స్ ఆఫ్ క్వశ్చన్స్ ఇచ్చినప్పుడు ఖచ్చితంగా వర్డ్ ఫార్మేషన్ మనకు తెలియకుండా ఈక్విఫరెన్షియల్ ఫార్ములా ఇస్తే ఈజీగా రాసేస్తాం. సో ఇట్స్ a very, very important concept for the basic information. By using this basic information, valence, already we know about the valency. Next we have to go to the simple definition, that is called oxidation. Why do I have to go to the oxidation? So both valence and oxidation both are same. How can you differentiate the valencies and oxidation state? I have to clear that. I know you all are understand the word formation to equation form. We can take more another examples, and also we can easily formation the different equations, word formation to equation form by using valency factor. By using this valency factor, we can also find out the oxidation state of the particular element. So particular element, in the example, all metals, we can take any metal, sodium, all metals of loss of electrons, and non-metals, all non-metals of gain of electrons. The loss of electrons can be signed as a positive, the gain of electrons is signed is defined as a negative. Again once I have to repeat. So the loss of electrons can be treated as a positive charge, gain of electrons is treated as a negative charge. So take one more example, we have to take NaCl, sodium chloride. So we don't know about that, we have to cleavage like this. So sodium and chlorine, I know this is the first group and this is the seventh group. All first year group and second year group elements are metals, all S block elements are metals, all metals loss of electrons to attain a positive charge. Next one, for non-metals, so gain of electrons, that is called to attain a negative charge. If we have to go to the NaCl to loss of Na plus, how many number of electrons are lost? Only 1 electron. So that is called valency. We know about the valency. What is the valence of sodium is only 1. If the sodium, how many number of electrons are lost? Oxidation state is a very, very important concept. Oxidation state. What is the oxidation state is? plus 1. So you have to write what is the differentiate. How can you differentiate the valence and oxidation state is by using sign only. If we have to know sign, that is called valency, that it is having a sign, that is called oxidation state. Then we have to go to the chlorine. Already in a chlorine atom, in chlorine atom outermost configuration, the outermost configuration has a 3s2 3p5. So chlorine 3s2 3p5, how many number of electrons are gained? The only 1 electrons, because of already it has 7 electrons. 7 plus 1 to equal to 8 electrons. That according to octet it has 8 electrons. So that's why chlorine has the valency, because of only 1 electron is gained. Basing on their gain of electrons to get a negative charge, so this is called -1, because of chlorine exists as a -1, because of it gain of 1 electrons only, that can be written as a -1. So how can you differentiate the valence and oxidation state? Is nothing but valence having a no sign, but oxidation state having a sign. Similarly, we have to go to another example, like a MgCl2. Already I said that magnesium chloride how can exist as a MgCl2. How can the cleavage? This is also one of the important. Most of the students can be wrong in this. Magnesium chloride Mg plus 2 plus 2Cl minus, this is the correct answer, not a Mg2 plus, it's a wrong. Similarly Mg2 plus, this is also wrong. Next one, so Cl2 minus, this is also wrong. Next one, Cl minus 2, this is also wrong. So most of the students can are wrong like this. So this is not exist. How can I explain? Because of already magnesium is a second group, it loss of 2 electrons, but here the magnesium loss of only 1 electron. So here magnesium is 2 electrons. That's why it is not a correct. So it is that's why it is a wrong. So one magnesium loss of 2 electrons, but here 2 magnesium atoms loss of only single electrons, but magnesium loss, the single magnesium atom loss of 2 electrons, but here the all are the only 1 electrons. So that's why this is the wrong statement. So this is the wrong. Similarly, the single chlorine atom gain of the single electron only, not a 2 electrons. So here the 2 chlorine atoms, these 2 chlorine atoms can be cleavaged like this, Cl and Cl minus. So that is, it has only 18 electrons. So it has only 17 electrons. It is a octet, it is not octet because of 18 electrons. If an element outermost configuration 8 electrons, so it is a octet, is a stable, but it is not a stable. Similarly here chlorine has a 17 electrons, but is the Cl minus 2, that is a 19 electrons. So it is not exist because of nearest noble gas is argon, so it is the 18 electrons. But Cl minus is 18 electrons, but Cl is 17 electrons. If Cl can be converted into Cl minus, the minus is nothing but gain of electrons. How many number of gain electrons? Cl minus is nothing but only 1 electron to convert it into argon. So it has the 18 electrons, can be easily stable. So my dear friends, so don't forget this. These are the, and this is the, these two are the wrong statements. So this is the right statement for the cleavage of the equations. MgCl2. Similarly, go to AlCl3. So we don't know about that. Aluminum, what is the group number of the aluminum? We don't know. Then go to the same basic concept. Aluminum is atomic number 13. Outermost configuration is neon, 3s2 3p1. What is the group number? So power, summation of the powers is equal to 2 plus 1 is equal to 3. So that group number up to 4th group number is equal to valency, that is equal to, so that is the 3. So loss of 3 electrons. Similarly, the single chlorine atom gain of single electron only. So we have to write this aluminum plus 3 chlorine atoms. So what's we don't know about the valencies. And if the chlorine atom gain of only 1 electron, here there are how many number of chlorine atoms? There are 3 chlorine atoms because of Cl minus plus, that is equal to 3Cl minus. Here all chlorine atoms gain of only 1 electron, but it is not can be treated as a Cl3 minus. So it is also wrong answer. It is also wrong answer. By using this basic information, we can easily word formation and also oxidation state of the particular element. This is the very helpful for the two combination. So this is the only for two elements only, but in a other components there are H2SO4 and oxidation state of the middle element. So this is also one of the helpful for to find the remaining concepts. So by friends, this is the only 10% of the basic I will given. So tomorrow I have to give the more basic information and we have to go to the molarity and normality problems. So in this molarity problem, so basic problems are very easily by using this formula, but another go to the different problems are there. We have to must know about the information of this basic information. I hope to understand all these concepts. So tomorrow I will continue the class. Thank you.
విద్యార్థుల భవిష్యత్తుకు బాటలు వేస్తూ మునుపెన్నడూ ఎరుగని అత్యుత్తమమైన ఫలితాలతో అద్భుతమైన విద్యా ప్రమాణాలతో ముందుకు దూసుకుపోతోంది శ్రద్ధ జూనియర్ కళాశాల. మహబూబ్నగర్ జిల్లా కేంద్రంలో ప్రముఖులు అనుభవజ్ఞులైన చైర్మన్ జగపతిరావు ఆధ్వర్యంలో 2011లో స్థాపించబడిన మా శ్రద్ధ జూనియర్